Hello guys, today I'm going to explain you how can we solve this problem from Hackerearth's June challenge. This problem was asked in June Easy challenge actually. It's based on dynamic programming. The question says that we are given a string and we need to find a subsequence of the string such that we can maximize the beauty of the subsequence. We need to find the subsequence which has the maximum beauty. Now how this beauty is calculated, I'll better read the example so that you can understand. So we are given a string and we are given certain number of pairs along with some values. All right, these pairs are going to play a role in calculating the beauty of the each subsequence that we will generate from this given string. And let's, for example, take this scenario like this is not from the given example. This is some hypothetical example that I have taken. So in this case we have a string, and what we need to do is we need to actually we need to find one subsequence of this which gives us the maximum beauty. Now let me explain you how this beauty is going to be calculated. So one such subsequence that we can have is A, and then we can have B, then we can have C from this one, and then we can have, let's say we took this B and C as well, so this B and C is also there. Now how this in fact let me choose one. So the beauty is calculated in such a way that what we will do is we will take pairs, and these pairs are the adjacent pairs from this subsequence. So the adjacent pairs are these A comma B, B comma C, and we have C comma B, and we have B comma C as well as the last pair. Alright, so each adjacent pair are here. So A comma B, B comma C, C comma B, and B comma C is here. All right, and then what we are going to do is we are going to find if we had some pairs which were from our given list. So for example, A comma B is there and one value is 4 and the other value is 1, so we can get both of them, which will give us overall 5 for A comma B, and then for B comma C we have 2. Then for C comma B we do not have, so it will be 0. These pairs are contributing some values to the overall beautiness of this overall beauty of this subsequence. Then and also for the last B and C as well we have 2. All right, so basically this gives us overall 9. That is the current beauty of this subsequence. The other possible let me just try to bring it up, and then is we can say it is A, B, D. We can choose A, B and D from here. And what are all the possible pairs that we can get from here is A comma B. If we just choose this subsequence, and we'll get B comma D. All right, so these are the only 2 possible pairs that we can get. And now let's try to find the beauty of this subsequence. So the beauty of this subsequence is A comma B will give you 4. We will have another A comma B which will give you 5 plus 1. Then for B comma D we have 23. All right, so this gives us overall 28. So this being smaller subsequence from this one, still it gives us better beauty. So what we need to do is we need to just try to find out the maximum beauty that we can get in this manner. So now I hope that you are able to understand the role of these pairs and their values that are given to us. So keep in mind that if B is to C is given, it doesn't mean that C is to B is also a valid one. So for example, here we didn't count value for C comma B when we were considering. All right, so now let's see how we can solve this. So the first thing that comes to our mind is how can we try to form a subsequence. So let's say we were in the beginning at at any moment we were somewhere here. We had chosen b as our previous element into our substrings. Let's say our substring was something like this, and b was b was the previous character into our subsequence. Now if we are at this index, we can choose any of these value for the next to be the next character in our subsequence. All right, so what we can do is we can we can try all the possibilities. Like we will try to choose c as the next character into our subsequence, and then from c onwards we will recursively call our function for the rest of the strings. All right, and if we chose d instead of c, so we can simply say, let's say we chose this one, then we will try to call for the rest of the subsequence, rest of the string, and will in the same way we can try to solve the underlying sub problems. All right, so what happens when we, let's say for example, we said that we are going to choose this d. All right, so what happens now is we will not only choose d, so d becomes the next next character into our subsequence. We will also add the gain that we can have by adding b to c as our because now in our subsequence you can see these two are adjacent, so we can possibly gain something from our pairs list, and we will try to see if b is to d is there. So whatever value is there into our list of pairs, we are going to add this one. So in this case we will add 23 to our answer by answer for choosing b is to d, and then we'll recursively find the answer for the rest of the strings. Similarly, we would try to make a make a jump from b to this b, and then we'll see if there is anything in b to b. If there is anything, then we will try to add, but here there was nothing, so we will not add anything, so this will be 0. But you cannot say that we are at any moment we can only choose the maximum one, because let's say even if we choose b to b here, or this is not the, let's say, yeah, if some moment we chose c to d and c to d was not here, but choosing d could have given us a better result at some point later. So we will, that's why we are going to try to jump from each string to, each possible character, jump from the current character to each possible character in this string and try to find out the answer. So this is one way of trying to do this, trying to form the subsequence and finding the answer. But does this approach work? Let me try to explain you why this approach wouldn't work. Let me quickly explain you through this code that what I was explaining you about, and then I'll explain why we can't go through this method. And yeah, let's see. So here I have just taken the input, and here the string, the length of the string, and the number of the queries, and then for each query I'm getting this a, b, and k. So a and b are the characters and k is the value. And then instead of storing a and b separately, what I'm doing is storing them uniquely. So for a and b I will be adding 5 to my map, so that whenever I'll get this a is to b pair, I'll just call my map to check if there is any value in for this one or not. And similarly, yeah, and then here I'm trying to, so yeah, one thing we can notice that a subsequent can start from 0th index, or from 1 or 2 or so on. So that's what I'm doing. I'm starting from each of them and trying to find out the answer for for the subsequence starting from that particular character. So let's say if we try to start from 0, then it will be solve of 0 comma the current character at this one, so the ASCII value of current character of this one. So the ASCII value, because I am trying to store it in because I'll need to memorize, and for that I'll need to have a DP table, and that's why I have I'm taking the ASCII character. Otherwise I could have chosen map to store the DP state, but maps are a bit slower. So yeah, and then what I'm doing in my solve function is that I have index of the current chosen character and the current the ASCII value of the chosen value. Then what I'm doing is, so for example, if I had chosen till d, and if d was let me just write it down here, if d was the last character, then what we can do is we can try to start from the index for d onwards, So for B, C and A, and that's what I'm doing for B, C and A, starting from idx plus 1, the current index plus 1 till the end of the string, and then I'll try to find the answer for this one. So what happens here is, now if I choose a particular I, then I'll say that I have chosen till I, and then the previous character that I will be choosing is the x of I, and because we are storing it in the ASCII, storing the ASCII value, that's why I'm subtracting the minus a here. And then what's the gain of choosing this particular one? So this will be the value that we have stored here. Then we'll try to find out the answer of out of all the possible scenarios that we can have, and then maximum will be the best answer. And here I'm memoizing it. So this doesn't work because, as you can notice here, the value here is the complexity here is basically O of n square into 26. So basically here we have n is up to 2 raised to the power 5. So 2 raised to the 2 into 10 raised to the power 5, let's just call it 10 raised to the power 5. And in here what we are doing is we are again traversing from current string to the from current index to the end of the string. So this will also be O of n only, and so overall it becomes O of n square. And because we have another state also, so this will be a factor as well, so it is 26 of O n square, which is way too huge to pass the test cases. So what optimization we could do, let's talk about that. Now let's recall what we were doing. So if you remember, we were trying let's say at any moment we have found a subsequence which is ending at B at this position, and then what we were doing is we were trying out all these letters ahead of this one. So we will possibly try on all these characters, all the letters in this substring. What optimization we could do here is, because we know that these all are alphabetical letter only, all the English alphabets only, so, and those are only lowercase, so there can be as many as only 26. So why not try for all the possible ones, let's say from starting from A till Z, and then find, like, what I mean to say is, try to see if there is a character A which is lying ahead of this index at which this B is, and we'll try to find it in this particular substring. Similarly, we'll try to find for B and for C and for Z and so on, and for whichever we find that yes there exists, for example we found that there exists a D ahead of this position, then what we are going to do, we will try to do the same thing that we were doing with the D previously. We will check if there is a gain in if we have a pair in this pair list, then we will add the cost as well, and then we will recursively call for this index onward. So how are we going to do this? Like, how are we going to find whether there exists any character in front of this particular index? We can easily do that by doing a binary search. So we know that if we can somehow store all the indexes, all the occurrences of each letter, like for A, for B, for C, for D, and so on, like till Z, if we store like which are all the position this A is occurring, like 0 to 4. I'm just saying in this case it is only occurring at 0 in our, and then B is occurring at 1 and 2, 3, 4. Then C is occurring at 2, 3, 4, 5, 6, and so on. We can store. Alright, so now if we are at index 1 and we want to find if there exists A which is ahead of this one, so we can first of all we can store this as a map of vectors, or we can try to I can talk about this separately, what kind of data structure we can have, or I will show you once I'll write the code. So what's the easiest data structure that can give us? So in such a manner that what I'm trying to say is we can store the occurrences for each letter in a vector where, or some sort of data structure where we can do a binary search on this particular index. So we'll try to find the index. Let's say for this one, the index is 1, and we'll try to find if there exists any index which is more than 1, any value which is more than 1 for A, and if we found, then we will try for A. Otherwise we'll even if we find or not, we'll go for next one as well. So whatever the answer we'll get from A, we'll then compare it for B, and then we'll compare it with C. And the rest of the logic is pretty much similar. So let's try to understand it better through the code now. So yeah, let me walk you through this code. So most of the things are very much similar. As I said, there is one more thing that we are doing. I have declared one array of set. So basically this array of set will store the occurrences of all the characters in this string. Like 0 will store a set for, we are storing a set for 0 to store all the indexes where the A is occurring, and then similarly for B and C and so on till Z. And this is how we are storing it. So we are just calculating the ASCII value and then inserting the current index at which this particular letter has occurred. And then, as we were doing in the previous approach, that we can have a subsequence starting at any index. So we'll try to start from every index possible, and then we'll compare it to the maximum answer. Then here now, as you can see, we don't first of all rely on the previous character that we choose, and because we don't care about what was the character that we choose, we just care what was the index that we have chosen previously. So previously we have chosen this particular index, and then for the next one, what we are going to do is we'll try out all the possible A to Z, and then we'll check. So here is the part where we are doing the binary search to find out the index. If you remember, I was explaining that from here, from this position where the B is lying, like at index 1, if we want to find out which is then if there is any index where any of this A till Z is lying or not, so we can do a binary search on the set where we have stored all the occurrences of each letter. So for example, if we wanted to search for, let's say, I equals to 0, that means for A, so what we are doing is we are doing a binary search on the set of A and finding out the index of A. So once we find out the index of A, first of all we will check whether there was any such index or not. If this iterator is end of the set, that means we didn't find anything. So that means A does not exist out ahead of this particular index, and we need to find some other index. And if we take A exists or any other character exists, then we'll try to then we'll consider it as a possible candidate. And what are we going to do? We are going to then add the cost of add the gain, the profit that we can get by adding this pair. So this pair will give us the this amount. This is the amount for having a pair of, let's say, for example, if the previous was idx, so we'll get the ASCII value of the previous character, and we can get it from the previous index, the correct index, and then whatever letter we have chosen. So, and then this star of it is dereferencing this current pointer, that means the index at which this particular letter was found. So this is the current index, and it will be the previous index for the next state. So, and then what we are doing is we are finding out the answers, and then storing the maximum of all the possible answers, and then just memoizing it the way we were doing it previously. So the key part here is the realization of the part that we don't need to traverse from idx plus 1 till all the way to the end of the string. We just need to consider the only 26 possibility that we can have, and then to find out whether let's say out of these 26 possibilities of A to Z, if let's say if we want to find out whether there exists any index where this particular character exists or not. Let's say if we were to find out whether ahead of idx. We want to find if there exists let's say for example p or not. Then what we will do is we will try for position of p, I mean the ASCII value of p, and in this set of p. So we are going to do a binary search uh, on this position of p set, and the value that we are going to search for is the current index. So it will give me the first index which is greater than idx. Alright, so now as you can see, the time complexity has improved from O of n square to O of n log n, and yeah, this should be fast enough to pass all the test cases that we have. And that's it guys. I hope I was able to explain it properly. If there is anything which is not clear, or if you have any doubt, please let me know in the comment section below. Or if there is any feedback or any comments that you have for me, or any suggestions, please do leave that as well. And if you haven't subscribed to my channel yet, and if you like my work, please do subscribe to my channel. And yeah, thanks for watching this video guys.